what we do. So Myco Gulf is a part of a Myco holding company in Germany. We have two sister concerns. One, Myco Italia SPA in Italy, and then Myco Gulf LLC based in UAE. Myco Gulf LLC was established in the year 2005 to cater to IMEA region. We started our journey in Jebel Ali Free Zone in Dubai, and then we moved to a bigger manufacturing facility of 40,000 square feet in Ras Al Khaimah, where we manufacture Eurovent certified air handling units, AMCA certified range of box fans. Can I ask others to, if they can mute their mic?
Adjusted baseline minus the actual reporting period يطلع معنا السيفنجز ب units gas.
Yes, thank you. We manufacture AMCA range of certified products for inline fans, box fans, roof fans. We are specialists in car park ventilation system. We have in-house certified CFD engineers who do CFD analysis for car park ventilation. We also manufacture kitchen ecology unit, which is again tested as per UL 710 standard. So I would like to play this short video about a corporate.
NEMA stands for NEMA اللي هي National Electrical Manufacturing Association.
Dyner brand has become synonymous with the word ventilation. It has been present in the global market since 1980 and has been proud to be associated with a lot of prestigious projects across the world. In 2014, we decided to build an AMCA standard test lab which could test air movement products as per AMCA standard 210 and 300, the most widely accepted global standard for air ventilation equipment products. The lab got accreditation in February 2016 and has the capacity to test air movement products from 640 cubic meter per hour to 140,000 cubic meter per hour and is one of the first labs in the Middle East to achieve this coveted feat. Dyner products manufactured at our Iraq plant in the UAE carry the AMCA certification for air and sound, which offers trustworthy solutions to consulting engineers, specifiers, and MEP contractors for their projects.
Yes, this is about our corporate video. I would like to reiterate again, Myco Gulf is one of the first companies in the Middle East to be certified and accredited by AMCA USA to test air movement products for air and sound performance. And what does it mean to us? I mean, we are not authorized to do only for our products. We are licensed to do even for other products for air and sound performance. So we take pride in that. And Without taking much time, I would like to invite my colleague Engineer Anish to take over the session. Anish, over to you now.
Anish, you are on mute.
Anish, your mic is off.
Anish, you're mute.
Hello, sorry. Thanks a lot, Asif. Once again, Ramadan Kareem to all of you. Thank you for giving us this time to present ourselves and basically to share our technical views, what we have on fans and our expertise for the so long years. As Asif has already introduced about our expertise, so I will not take much time. Directly go to the presentation. Just let me share the screen to you. Asif, is it viewable?
Yes. Yeah.
Okay.
Yes, it's fine.
So,
Go ahead.
okay. So let me start with, so today we are talking about fan energy index. That is basically a new term which is gone, which you as a consultant, as a technical, as a mechanical engineer will be hearing in the future. So what is fan energy index? I will come to it later, but before that, let me first give you a small idea of what is it related to. So I guess all of us is aware of fan efficiency. A fan, when it is selected for an application, as a consultant, as a contractor, as a client, the first eyes goes to the efficiency of the fan. What is the efficiency of the fan? Basically, fan efficiency is nothing but uh, the, a ratio which is directly proportional to the static pressure or the airflow and the power kilowatts. It is basically showing us the how much energy is being consumed in terms of efficiency, in terms of the kilowatt rating. So you have two efficiencies, one is static and one is total. Static efficiency is used when you're using a fan without a duct, and total efficiency is used when you're using a fan with the duct. So what is total efficiency? It is a ratio of the product of airflow and total pressure. Total pressure is nothing but static pressure plus velocity pressure. As you all are aware, when a fan is running, when there will be a static pressure which has to be overcome by the fan, that is the duct losses which the fan has to overcome, and then there is a velocity pressure, that is the energy which the fan impeller is converting to overcome the static pressure. So basically, overall total pressure will be static pressure plus velocity pressure, and velocity pressure is always directly proportional to the outlet velocity of the fan. So in short, total efficiency, which is a major concern for us now, because most of the applications what we use in our day-to-day MEP devices is all connected to duct. So total efficiency is directly proportional to the fan outlet velocity. However, it doesn't mean that you, to achieve the maximum efficiency, you will select a fan with the maximum outlet velocity, because there is a limit, because outlet velocity higher will have its own impact on the sound levels and the overall performance of the unit. So as a consultant or as a engineer, basically you would be facing issues of what is the specification of a fan. So what are the main constraints every engineer faces is, what is the minimum efficiency I should specify for selecting a fan? What is the minimum kilowatt rating I should be thinking of? Because you will be having almost 3 or 4 selections from 3 or 4 different suppliers. How will you select the right model? What is the optimum fan sizing? What is the right sizing for that particular application? What is the outlet velocity I should limit? So what is the sound pressure level? So basically, these are the 5 constraints which normally every engineer who is selecting a fan will be facing always before he approves or he says, yes, this is the right fan. So for all these queries, AMCA, as Asif had already defined about AMCA, AMCA is an international body from America who is looking after the performance and the certification of fans. So it is a body which certifies, yes, this particular fan which is selected for this capacity is the right fan, or it is the performance mentioned is proper as per the catalog. So AMCA has come up with something called as fan efficiency grade, which normally now at this stage, most of your technical data sheets from different suppliers will be mentioning, because this was introduced by ASHRAE 90.1 in 2013 edition. according to this, if any fan is giving you an FEG rating above 67, is the right selection. So what is FEG? FEG, I will just explain to you. I will explain to you. So basically, I guess someone is not on mute. Anyways, let me continue. So FEG 67, any fan which is above 67 will be the right selection. And this selection is based on 15% of the peak point. So there will be some of the other exemptions always, because emergency fans are not considered FEG grade. Impellers or fans below 2.7 kilowatt.
Anish, you have to announce
hello?
to switch off the mic. Can you announce switch off the mic?
Yeah. Excuse me, I guess some of you are not in mute. So if you can be in mute, it will help everyone to
Switch
listen
off
to
your
the
mic, please.
presentation.
Can you switch off your mic, please?
Yeah, thank you. And the next is like heat distribution systems, like heat equipment, boilers, and all are not considered an FEG grade. Now let us talk about what is FEG grade. So FEG grade is just a function. It is a grade which is defined by AMCA based on the total peak efficiency of the fan. It doesn't mean that the fan selected or the efficiency which is shown at that moment is based on the flow requirement for which you have selected the fan. It is a grade which is defined by the total efficiency of fan. So it is a bandwidth which is selected for different models, and based on the total peak efficiency, they have graded that fans. That grade, for example, FEG grade 80. You can see the different diameters on the x-axis and the total peak efficiency on the y-axis. So if you see FEG 80 means all the fans which is falling in that grade where the total efficiency is between 70 and 75 or 80. So it is a grade, it is a band, it is not giving you the actual picture of what efficiency or what capacity the fan is selected at. So this is a very simple scenario. A small example which we have selected with different models for a particular capacity. If you see on the left hand side, this is the model numbers or the different diameters at which we have selected the fan. So if you see, the actual efficiency of the fan is varying from 40 to 82. But if you see, the grade is all same, FEG 85. So this was a drawback, because this FEG grade is defined with the peak efficiency, which is always, if you plot any graph of any fan, the peak efficiency will always be like 70 to 80. And the FEG grade is only considering the peak efficiency. It is not actually considering the actual efficiency, which should be our concern for any selection. So that means if I consider FEGs, as Ashley has said, any fan which is having FEG above 67 is the right selection. So in this case, you can just have a look that all these diameters are having efficiencies which is varying from 40 to 83, but the FEG grade is 85. So if you select, okay, FEG grade is 85, you can even select this fan which is having 40.1 efficiency, or you can even select this fan which is having efficiency of 82.5. So this clearly says that FEG was not the right statement or not the right point where based on which you should be selecting the fan. This was a drawback which was found out later by AMCA, because FEG was based purely on the peak total efficiency of the fan and not the actual efficiency. So these were some of the shortcomings. So FEG was clearly based on the peak total efficiency of the fan, which can vary to fan model sizes, and which can be higher always, because peak total efficiency will always be about 60 and 70 for any graph. FEG rating applies to all fan models, so it doesn't mean that it is based on the actual duty point at which you are selecting that particular fan. It does not truly give an efficient fan selection. We just had a look that even a fan with 40.1 efficiency is also giving you FEG grade 85, but that doesn't mean that the fan is the right selection. It is not considering wire to wear. I will just define this wire to wear. What is it in the next slides? Bare shaft. This also you will just see in the next slide, and it is not at all concerning about the losses in the motors and drives. It is only about the shaft, how much air is being converted from the shaft. I'll just come to it now. So we were just discussing on wire to shaft, wire to air. So this is what, for example, any fan has these things always in it. So basically what you do is you will give the fan power supply. The power supply goes to the controls. The controls will then go to the motor. You will give power to the motor. From the motor, if it is a belt driven fan, it will go to the transmissions like pulleys and belt, and then the fan will move. So basically FEG is not considering the losses which you have right from this point till this point. FEG is only considering shaft to air. So in short, now if you see here, any fan which is running will have these losses. The first loss will be motor loss. There will be some loss in the motor. This 10% is based on an approximation that we are selecting an IE3 efficient motor. There will be always drive losses because transmission losses will always there. Bearing losses will be there because there will be slip losses on and off. Then aerodynamic loss based on the impeller, based on the fan design, and finally the fan output. So here if you see, this is what FEG is considering. FEG is only considering this part, the fan power at the shaft. However, your total requirement is this. You need to consider the losses from wire till air. So the point when you give the power supply till the point the output what you're getting. Unless and until you don't consider the whole losses, the selection of fan or the efficiency and whatever grade you're looking at is not the right one. So to overcome all this, AMCA introduced fan energy index. This was introduced in AMCA 208 standard in 2018, and then later on it has been widely accepted, and now even ASHRAE 90.1 has accepted this. So let us look into how FEI solves the problems of FEG. As we discussed earlier, FEG was only considering the shaft to air. It was not considering wire to air. But here FEI is clearly considering this. It is considering all these losses. It covers the fan, the transmission losses, the motor losses, the drive losses. It even considers load conditions, which was not considered in FEG. It can account for static and total pressure as required. That means if you have a ducted system, it will be total pressure. If you have a non-ducted system, it will be static pressure. And it selects the most efficient fan. I will just show you how it selects the most efficient fan. So this is a comparison between FEG, which is prevailing now, and FEI, which has overtaken FEG. FEG is nothing but fan efficiency grade, and FEI is fan energy index. So what is the criteria of FEG? It is peak total efficiency, which I discussed a few slides before. But FEI considers actual efficiency. Now, when you select a fan, the fan rating point in FEG is best efficiency point. That means you have 1000 CFM at 100 Pascal. This fan, if you are considering an FEG grade, this will see what is the maximum efficiency possible for that fan, but it will not consider the efficiency at what fan the fan is running when you selecting the fan for 1000 CFM. However, FEI will select the actual duty point. So this is a major difference of FEI and FEG. And then yes, it is an indication of brake horsepower for FEG, and FEI is the actual indication of the power. That is the power supply which you actually need to drive the fan right from the considering all the losses in that fan. So what is fan efficiency index? It is nothing but a ratio of a reference fan. Now, what is a reference fan? It is a fan which AMCA committee in AMCA 208, they have defined that for this particular capacity, if this is the static pressure, if this is the flow, then the power supply for this particular fan should not be more than this. So that is the reference fan. This is based on some calculations and assumptions which they have taken after considering a lot of data from different type of fans. And based on that, we compare that reference fan to our selected fan. So it is nothing but a ratio. Now the reference fan and the selected fan will be selected at the same airflows. For example, 1000 CFM at 500 Pascal, the reference fan will give you a particular power rating, and our fan will give you a particular power rating. So it is actually comparing apple to apple for that particular capacity. This is the mathematical formula of how the power rating is considered. This will be mostly used by most of the softwares in all the fan selection softwares. So basically here what we are saying is that we are trying to find out the power for that particular fan, and then we add up the losses. The AMCA belt losses is based on AMCA 203 and the motor losses. So finally we come into the reference fan power, electrical input power. Now I am moving on to that same sheet which we were discussing earlier on FEG, where we were getting different fans, different flow, different actual efficiency, but the same FEG. Now we have added the FEI. Now if you see here, the FEI is varying from different fans. Earlier, we were getting a same grade for all actual efficiency. Even the smallest efficiency was having the same grade, and the highest efficiency was having the same grade. Now, if you see, the FEI has changed. The lowest actual efficiency is giving you 0.67 FEI, whereas the highest efficiency is giving you 1.39. So now this indicates how FEG is obsolete and why it is obsolete. So FEI will give you the actual comparison. If you select the models which are giving you FEI above 1, you can see most of the fans which are coming in that bracket are above 70 or above 65 actual efficiency. So this shows that this would be any fan which is selected in this range would be the right selection. So what is the standard what we should follow for FEI? Basically, FEI as per ASHRAE 90.1, any fan at the design point, if that fan is giving you an FEI rating above 1, that is the right selection for that particular application. So if I go back to the previous slide, any fan which is giving you a ratio above 1. So if you see diameter 24 inches to 36 inches is giving you a ratio above 1. So that is what I was telling you. The efficiency here is all above 65 minimum. So this is the right selection at that particular duty point. So ASHRAE 90.1 clearly states that any fan efficiency index which is above 1 is the right selection. ASHRAE 189.1, which is basically used for lead applications, states any fan which is having FEI above 1.1. And US body also states FEI above 1. This is the criteria which will be coming up for henceforth for selecting any fan which will give you the right selection. Now, to confirm that, sometimes there are questions asked like, what is the right point of selection? In a graph, how will we know which is the right selection? So this will give you a small idea on it. So this is a pressure airflow curve in which you will see that when you are plotting the FEI, which is this line, and you are dropping it down to the fan curve, you will see this is the range of selection, which is the optimum selection band. So any fan which your operating point is falling in this range of the fan curve will be the right selection. You go above this, your FEI will go down because this is the ratio. This is the line of FEI 1. So if you go above this, your FEI will fall down to below 1 here, this point. And similarly, anything below this point will be FEI below 1. So this range will be called as the stalling region, which is not suitable for selection for any kind of fans. No fan should ever be selected in this range. So the best compliant range of fan, the operating point should be falling in this range of the fan, the red mark. And if you see these points, which is dropping down to the FEI 1, it is falling into the correct range. So any fan selected in this range will be FEI above 1 or minimum FEI 1. This is the further breakdown of that same graph when you plot it in different RPM curves. So the right hand side fan is a non-efficient fan and the left hand side fan is an efficient fan. If you see the bubbles of FEI, this is the FEI bubbles. The same curve which I was showing you earlier, it is further developed like this. So if you plot a bubble like this, it will fall into this sector. So this is the FEI 1 bubble. Similarly, the same thing is shown here in different RPMs. So on the right hand side, if you compare this fan, you select this fan which is having an FEI at a lower curve, at a lower RPM. But when you are using it at a higher RPM, the FEI falls down. So the FEI is not compliant, FEI is less than 1. But so this fan is not the right selection. But if you select this fan, where your highest fan is falling in that FEI 1 bubble, highest flow, when the flow falls down, the FEI is increasing. So this shows that FEI is taking into consideration the part load efficiencies also. It is taking care of the part loads what is falling on the fan. So this is why FEI is far different than FEG and far better than FEG. So what is the status of FEI as of now? ASHRAE 90.1 August 2019 edition has already incorporated this in their editions, and which clearly states that as per ASHRAE 90.1 2019, any fan if selected above efficiency FEI 1 is the right selection. ASHRAE 189.1 also in the coming 2020 edition, they will be incorporating FEI. IECC standard will also be incorporating it in the 2021 edition. So finally, all the agencies which we are related to, the HVAC world is related to, has accepted that fans should be selected based on the fan energy index and not the fan efficiency grade. So anyone who is coming with you for any selections, the first point to be asked is, what is the FEI? If you are selecting the fan of FEI above 1, yes, that is the right selection. You may have 2 or 3 selections. FEI 1, 1.2, 1.3, 1.4. Then it comes for you to create a balance that yes, my lower cut is FEI. I should not select a fan below FEI 1. Above FEI 1, I should make a balance with the size of the fan, the cost of the fan, and the sound levels of the fan. So you have to create a balance, but your cutoff should be FEI 1. You should not select a fan less than FEI 1. So the manufacturers normally do this test with some of the AMCA standards. The rating test is normally done with AMCA 210 standard. The part load calculation, that is the losses from belt, VFDs, etc., is taken by AMCA 207, and FEI is calculated based on AMCA 208. So you can get all these resources from AMCA websites. There are complete resource on the FEI index also. And yes, you can always come back to us for your queries. And now I'll just give you the chance of asking any questions if you have on the presentation what we presented. Asif, I guess you can ask some questions if anybody wants to ask.
Yes, anyone has any questions, I mean, they can put it across to Anish, and we'll be happy to answer.
I have a question. Can you hear me?
Yeah.
Can you please introduce your name and what company, and then with your question, please?
Yes, sure. Assalamu alaikum. My name is Tariq Zainuddin. I'm a consultant at the University of Qasim in KSA. I have a question regarding Mr. Anish, regarding the table you have presented, the FEI and the FEG.
Okay.
In this table, let's imagine, and probably this will be for Mr. Sandeep too, you have a client will come to you and will ask for a fan size, let's say 18-inch, but with an efficiency, an actual efficiency, let's say 65. What would you do in this case?
Yeah, that's a good question. See, I will first go back to the first slide of mine. If you see, a fan efficiency is related to the airflow and the static pressure. So it doesn't mean that 18-inch would actually give you that capacity. For example, if your flow is not giving you that efficiency for that particular dia, then you are asking like 18-inch and getting a selection at 65 or 60 efficiency will be difficult, because efficiency is purely dependent on your airflow and the power motor rating, what has been installed there.
So the answer will be impossible to get this type of fan with this kind of criteria.
It purely depends on the airflow rating, sir. Your airflow, what is required, and the static pressure. So as a fan manufacturer, as a fan selector, what I would do is I would put that airflow and the static with a constraint that you need minimum 60 Pascal or 60% efficiency. And I will select a fan which will give you minimum 60% efficiency.
Okay, the second question.
So that will be my criteria.
Yes,
I will not go into the diameter.
Yeah, I would like to add, engineer, here. What's happening is this FEI is basically giving you the most optimum selection. Yani, you can select an 18-inch fan. There's no problem. The problem is if you look at the RPM, I can go back to the table and look at the power consumption. It's taking 11.8 highest brake horsepower. So it's not a very efficient selection, but I mean, but it is coming in FEG 85, and technically you can do it, but it is not a very wise selection. Now, if you look at the other extreme, you can select a 36-inch fan, but then that's too big, and then it will give you the space constraint. The fan may not fit. So that's the reason FEI says that if you're close to one, so that will give you the most balanced selection, you know, where you have the best efficiency point, reasonable power, you know. So this is what you call the most optimum selection.
Okay, thank you very much. That was my second question when it comes to the power consumption. Majority of the people now we are just so focused on energy savings.
Yeah.
So
Yes.
I thought you will be saying to the client, for example, I would advise you not to go because in this case you will be consuming much more power than if you go to a different size fan, and at the same time you will have a better efficiency. That's all.
So that is why,
thank
sir,
you so much.
FEI is basically designed to select a fan with the best efficiency and the minimum power rating. So if you see anything above 1, if you see the power kilowatt fallen down, and anything less than 1, the power is rating high. So if in this part of the world, when we are all concerned about saving of energy, FEI is the right point or right selection to be done for any fan.
Thank you very much. I appreciate it. Thank you.
Any other questions? Please, you can put it across.
Or if you can think of later, also you can email it to Asif, and then we can answer it.
Anytime, yes.
Yeah,
you can reach us, and we'll get back to you with the reply. I think there's no more questions. I would like to invite Mr. Sudeep to just give a closing remarks, and we can conclude. Before that, I would like to thank Engineer Haddad for giving us this opportunity, and Mechanical Webinar Group. We really thank them, and over to you, Sudeep.
Thank you, Asif, and thanks, Anish. It was a very good presentation. Well, I think just to summarize why FEI is important, I think I already said that when the gentleman asked the question is, it is giving you a very balanced selection, which basically takes care of the best size, the diameter of the fan. The size of the fan is also important because it has to fit the dimension wise and the cost, the first cost. So it really gives you a very, very balanced selection in terms of the size, in terms of the airflow, the duty point, the selected static pressure, and the power consumption. So it really has a very good balanced, criteria. And I think it happens, it helps consultants to put it in the specifications, like FEI should be equal or greater than 1. So that basically answers all the questions instead of writing the minimum efficiency or minimum BKW or BHP. So in fact, apart from FEI, now Dynair has come up with some products which is basically related to the current scenario. What we are facing is this COVID-19 pandemic. Anish, can you go to the slide, the last one? Yes. I'll just take only 1 minute because this also has a presentation, but because we'll be reaching end to this, I'll just briefly explain. We have developed these special units for COVID-19, and mostly these are used in field hospitals or temporary hospitals where we create isolation rooms or isolation wards where all COVID patients are kept. And as you are aware that wherever isolation rooms it has to have a separate supply and extract system, because we cannot recirculate the air as the patient is having that virus. And when we are exhausting this air, it has to be cleaned, it has to be disinfected. So if you see the DEV filtration unit, Anish, can you move the cursor just to show which unit I'm referring? Yeah, this one, DEV. So this is just a filtration unit. It's an what it does, it extracts the air from the room. It has a fan section, it has a pre-filter, it has a HEPA filter. So what it'll do is it will filter the air, and it will also disinfect it. If you want to put a UV as an option, you can put an UV as an option. So which means when it is discharging to the atmosphere, we don't want the virus to go in the surrounding areas and infect people. So before discharging it in the air, we have to clean and disinfect it. So this particular unit is available in different sizes, and the similar smaller option, if you see, Anish, can you, yeah, IRE units, where Anish is moving the cursor now. Now this is something similar what I mentioned as DEV, but this is more in the indoor unit. It works as a purifier, which you can place it inside the room, inside a patient room or a reception or a conference room. And what it's going to do, it's going to recirculate the air, and it must have a UV. Yani lazim, it should have a UV because we are recirculating the air. So it has a fan section, pre-filters, HEPA filters, and UV section. So it will completely clean the air, filter the and disinfect the air to 99.9999, like 4 times 9%. So we are roughly 100% disinfection we're going to achieve. And the next is the decont. If you can move, yes, this is the one. This is just a sanitizing tunnel. These are put at all the entry points of the shopping malls or labor accommodation or sites, office, outside the mosque, anywhere where you have a lot of people going in and coming out. This sanitizing tunnel can be kept at the entrance, and any person who's going, because as you know that COVID sticks to our clothing, shoes, whatever. It'll stick to the surface, any surface. So the person who's entering any premises, when he has to go through this, as he will enter, there is a motion sensor, and as he goes inside, the motion sensor will trigger. It has a pump, nozzles, and there is a disinfectant, there is a liquid. So it's going to spray the mist on the person from all sides. So this is full 360 degrees from top to bottom and from all sides. And the mist is formed all around the person. So it will almost, I would say 90% or more than that, it's going to disinfect that person. And once he comes out, and then he can enter the wherever shopping area or the office areas. So and then we also have now Anish is pointing at the aerofoam, where is the aero shield. This is just a face shield which you print. This is used as a PPE, like doctors are using it. I mean, you need to use mask, but then over the mask this covers your face. It's a acrylic sheet. Basically, it covers your face, so it gives you an added protection against the COVID. So these are the 4 products also we have, and we have the technical details, data sheets, and the videos. So I think I'll ask Asif to circulate these, and at any stage we will answer any questions. And if you have any question regards to these units, please, you may ask now.
Sudeep, I think.
Okay.
Yeah, there's no more questions. So
no more questions.
Conclude.
Yeah, it's already late.
We can conclude now. Yeah.
Yes.
Thank you, Sudeep, for this information. Once again, I would like to thank Engineer Haddad and his team for this opportunity, and thank each and every participant who made it to this webinar. Really thank you all. And inshallah, we hope to join you guys again with some other topic soon, inshallah.
Yes.
Till such time, please stay safe, take care.
Yes.
Assalamu alaikum.
Assalamu alaikum. Masalam.
Thank you.